Hello everyone. In the previous class we were discussed about the one form and two form definition of those forms, and we were discuss about the exterior derivative and we were solve a problem on exterior derivative, right? So in this class we were prove a theorem. So the statement of this theorem is, let f and g be the functions and let pi and psi be the one forms on E3. Then prove that, look here, so we have to prove these three equations. First one is d of f into g equals df. This is f, don't get confused. So this is f, df dot g plus f dot d into g. And the second one is d of f into pi equals df wedge pi plus f dot d pi. And the third one is d of pi wedge psi equals d pi wedge psi minus pi wedge d psi. Okay, so this is the statement of the theorem. Okay, now let's start to prove this theorem. So now I am going to prove this theorem one by one equations. Look here, in the first one, from the hypothesis they say that f and g are the functions and let pi and psi be the one forms. Look here, first we consider the functions f and g, and pi and psi are the one forms. Now let us take d into f. We know that d into f can be written as del f by del x into dx plus del f by del y into dy plus del f by del z into dz. Similarly, now we have to write the d of f into g. Look here. So again we write d of f into g as del of f into g by del x into dx plus del of f into g by del y into dy plus del of f into g by del z into dz. Now differentiate this one, we get g into del f by del x plus f into del g by del x into dx plus, again differentiate this one, we get g into del f by del y plus f into del g by del y into dy plus, again differentiate this one, we get g into del f by del z plus f into del g by del z. Okay, now write this as a split multiplying all these, we get here g into del f by del x into dx plus f into del g by del x into dx plus g into del f by del y into dy plus f into del g by del y into dy plus g into del f by del z into dz plus f into del g by del z into dz. Now, so now we consider the coefficient of f and g. Look here. So now we have to take the coefficient of g as g of, look here, then the remaining is del f by del x into dx plus then this one del f by del y into dy plus del f by del z into dz plus f into remaining is del g by del x into dx plus del g by del y into dy plus del g by del z into dz. Now observe here. So now this two can be represented as g into, so now we know that, so this can be represented as a derivative of the function f. Okay, means df plus f into, this can be represented as d into g. So therefore d of f into g is equals to g into df plus f into g. So first condition is proved. So next we move on to the second condition. So our second equation, the second equation is d into f into pi equals df wedge pi plus f dot d into pi. Okay, so for that one, first we consider the, so first we assume the one form function pi, that pi is equals to summation fi into dxi. Okay, now we have to take the exterior derivative on both sides of this one. So we get d pi is equals to summation dfi wedge dxi. Okay, so now this is the exterior derivative of the function f. Now look here, so in this equation we have to multiply both sides by f. So we get f into pi equals summation f into fi into dxi. Okay, now we have to take the exterior derivative of on these both sides of this equation. So we get exterior derivative of f into pi equals summation exterior derivative of f into fi wedge of dxi. Okay, now differentiate this one. So we get f into dfi plus fi into df wedge of dxi. Okay, now multiplying this one, so we get df into this one df wedge of dx wedge of summation fi into dxi plus, and this one is f into summation dfi wedge of dxi. Okay, now from this equation, look here, df into wedge of, so this can be represented as pi. Look here, pi is equal to summation fi into dxi. Therefore, this can be written as pi plus f into summation of dfi wedge dxi. We know that extended derivative of pi is equals to summation dfi wedge dxi. Therefore, this can be written as d pi. Therefore, d of f into pi is equals to df wedge of pi plus f dot d pi. Hence, the second equation is proved. Similarly, so we move on to the third equation, that is d of pi wedge xi